So I've continued working on the layout of this PCB. Since the last video, I've just done some minor things like some additional length matching, maybe a little bit of cleanup on some of the traces. I've moved some components away from the sock itself, maybe to leave more room just for serviceability there and make sure that I don't have any issues with whatever cooling I put on top of this. Maybe a quick comment on that. It seems like I should be clear to mount some type of cooler on this. I'm just setting these to locations for something if I want to have a way to strap down whatever I might put on here. But I'm planning for the moment at least to just go with a passive cooling option, which is just a heat sink with a double-sided, thermal type of tape. And if I need something that is more aggressive than that later, I'll have to worry about that in future designs, or figure out how I would mount a fan on top of this if it's larger than what's going to fit right here. But anyways, I know when I go and use I have a Digilent Arty Z7, and it comes with no cooling whatsoever on it, and I haven't used it aggressively enough. I haven't found a way to really make a heat an issue on it. But maybe I'll get to that point with this board that I do need better cooling than just a passive heatsink. But that's what I'm going to start with. And I left the holes in case later I want to do something that requires some type of an anchor to the board. I have not found a cooling solution that I really like as far as an active type of fan setup. At some point, I think I would want a PWM type of fan where I can control the speed from the system itself. And instead of a 5-volt header, I would need more of a PWM header and a control within the chip to do that. But that's a future project, not worried about it on this board here. But then just a few other length matching changes I made, but this is pretty much the same as what I had in the last video. And if I flip to the back, this is what the back looks like for the moment. I think I'm getting close enough that I would be willing to order up some PCBs, maybe even have them fully assembled so that I don't have to deal with the soldering, which will be a challenge for me. This will be the largest, BGA type of IC that I've used before. And I don't have a lot of experience soldering BGAs, so likely scenario is that I will mess that up, but if I can have someone else assemble it for me, that could save me a whole lot of aggravation. And they would have tools like X-ray tools just to make sure that these get soldered effectively and don't have issues with any of the actual BGA balls or pads. But two things I thought I would try to get through in this video. One of my to-do items is to go into the actual software to program this, FPGA/SOC or this Zynq-7000. And I had made a note that when I did this layout, and this is based on a couple of reference designs like Phil's ZBrett and then also the Digilent Arty Z7, you need to configure the pins, which pins are you going to use inside of the tool set, which would be Vivado. And I thought I would walk through that and just see if I've done anything here that's not compatible or doesn't line up. So is my current schematic in line with what that tool can configure, and just validate that that's looking okay, the best I understand it. The other thing I thought I would do is just get in and see what is it going to cost roughly to produce these PCBs, either as plain PCBs or with the actual assembly done, all the surface mount taken care of for me. So I think I'm going to jump in first to Vivado here, and I just have a blank project that I'm going to start, and maybe I'll just call this Z7 validate pins. And I don't like spaces. I'm going to get rid of those. And it's just going to be an RTL project. And then I have to choose my part. And my part I've labeled on my actual PCB. So I'm just going to come over here and copy that out real quick. And so this is the part I'm using. And then as I look through that, I know I'm using the 484, so the CLG 484. And then it gets down to these 3 parts here. And I'm just going to go ahead and pick the, it looks like they're comparable. I think these are just speed ratings are the differences between these 3. So I'm going to pick this one here, the -1. And I think, is it the higher the number on the dash, the higher the speed rating, or else I have it backwards. But my specific part is this, which is slightly different than what I'm seeing for choices, but I think that's where the -1 is coming into play. Anyways, this is the part I'm going to choose. I think that is okay here. And then I'm going to go ahead and do a finish. And one of the things that you can do in here is create a block diagram. So, I could come in here and add sources and create all of my code basically for the FPGA side of things. I can also come in and create a block diagram. And I'm going to go through this really quickly. But this allows me to kind of graphically lay out some of the different IP blocks and connect them together and start to build out what this board is going to do at some point. One of the blocks I can put in here, though, is the Zynq processing system. And so I will do that. And I get this block here. And I can double click it and configure it. And I get something that looks like this, just showing me all of these, really the architecture of this, and lets me get in and start configuring different aspects of this. So the DDR is where I'm going to come in eventually and choose, which DDR memory am I using. Hopefully it's in the drop down. If it's not in the drop down, I can do a custom and I can set values I think that I need to match the timing. One of the things I might take advantage of in here too is I could run the DDR at a slower rate, I believe. And so this is showing I can go up to 534 megahertz, but all the way down to 200. So I have a little bit of concern with my address lines and just making sure that I've got all the length matching done correctly, especially considering different layers of the board and vias and where they are. The data lines, those byte lanes for the data, I'm pretty confident in those. Those all stayed on a single layer, and I'm not too worried. But the address and control, I've got more length to it. I've got vias in there, and there's more RISC. But as I was reading up, it seems like if I bring down my clock frequency a little bit, that really adds a lot more cushion into how tightly I have to have that length matching done. So I think this is at least what I'm assuming, and tell me if I'm wrong, anybody, but I could bring this number down if I did have problems running at this speed for my DDR. But I'll get to work with that and see if I can get my DDR to work the way I want it to work. Now, another thing I can do in here is go configure my I/O pins, and so I'll make this bigger. This is really small font on here, and I don't think I have a way of making it bigger other than I'll zoom in when I edit the video here. But I can come and choose the different things that I want to add into my build. And for example, I know I'm going to do some SPI flash, and I can choose, am I doing this a single 4-bit IO or dual quad? And if I come over to the right, then I'm just going to pick a single SS 4-bit IO. And when I choose that, then it changes the screen and it shows which pins. And it looks like I can also do a dual quad or a dual quad. And let's see, a 4-bit, 8-bit. I think this is the one I want right here. And so this is a quad SPI flash, single SS 4-bit. Let's see if I pick these others. It looks like there's additional bits that might be needed depending on which one I'm using here. But I'm going to go with this single SS 4-bit, I believe. And if I go look at my schematic, I can go into my processor and see that I have this chip select on IO1. And then I have this DQ 0, 1, 2, and 3. And then I get down to my clock, and that clock is on IO6. But as I choose this, I can now hover over this up here, the pin, and it's saying, okay, IO1 should be this SS, the select line. And then I should have, looks like QSPI 0, 1, 2, 3, and then clock. So that's my 0, 1, 2, 3, and clock. So that seems to line up there with this. And then I can come in and say, yeah, I want Ethernet. And if I expand that over here to the right, I can choose. It looks like Ethernet 0 is what I want. And then it's showing me 16 pins up here. So pin 16 should be my transmit clock. And back over here, then IO16 is my transmit clock. So that looks like that's correct. And then I'd work my way across this. And so then I've got data 0, data 1, data 2, data 3, and control. So data 0, 1, 2, 3, control. That looks good. Then I have clock that matched, and then receive 0, 1, 2, 3, and control. So then receive 0, 1, 2, 3, and control, and that ended up on IO27. Okay, so that looks like that's matching. Then I can keep going. USB, yes. And if I come over to the right, I'll go ahead and choose that. And it shows me my pins 28. Show me that 28 should be data 4. So here's my 28, and I've got data 4 on that. And then dir STP NXT, dir STP NXT, and then I got data 0, 1, 2, 3, clock, 0, 1, 2, 3 clock. And then coming back, I've got 5, 6, 7, 5, 6, 7. And so that, again, 7 should end up on IO39. That looks good. Let's see, I've got an SD card. And choosing that, SD0, show me pins 40 through 45. So if I go to my pins 40 through 45, that is going to be my SD clock, command, data lines, and clock, command, and my data lines. So that matches that there. Keep on going. I can say I want to do a card detect. And then I believe I now need to choose. And now in my case, I've got this card detect on IO47. And so I think I need to come down to the bottom and choose that I'm going to place that reset card detect. Oh, actually, I can probably do that right up here. So that would be 47 and 47. So I think I can just mark that here like so. So I am doing this set of pins for the SD card itself, and then there is a card detect that is on pin 47. Let's see, what else might I need here? UART. And if I look at UART and I come back over, let's see if we have that here somewhere. Coming up, it looks like I've got that on 14 and 15, so 14 for transmit. And 14, that would be this right here, UART 0, it looks like. So 14 for, oh, that's receive, that's transmit. Make sure I've got that correct. And so here I've got UART1 transmit and UART1 receive. So I might want to validate that I don't have those backwards. So I'll go do that later. But it looks like here I've got receive and then transmit. And maybe what I'll do is go take a look on the ZBRET real quick. So this is the ZBRET schematics, and I'm just going to search for UART. And receive, he has, let's just see where that's connected. So transmit and then receive. Transmit, receive. So I've got that to match. So I might double check that later. I'll take that offline and see, do I have that correct? And I could probably look at the ARTI also and see if there is UART on that. IO 14, they're using something different here, transmit, receive. So I think I'm okay here. So in their case, they were doing IO 14 for the transmit in, receive out. So label's a little confusing for me, but I believe that is correct. And so I'm going to assume that is the case, and I'm going to keep running with it for now. Then let's see, I'm not doing I2C, not doing any of these. Let's see, Ethernet PHY reset and a USB reset. If I go back over here, let's see, Ethernet. I did have one of those reset lines, I believe. Here's an Ethernet reset. I have that on MIO 9. So Ethernet reset on 9. And then I don't know if I had a USB reset or not. There's a USB reset. So that would be 46, like so. And then I think I'm running out of things. So the question is, do I have any others here that I haven't covered? So, you know, if I go to the top of this, MIO, I've just got an LED connected up to this. So this first IO0 is just going to be an LED that I can programmatically do something with. And this up here is showing me that it is just a plain old GPIO0. And then if I get in, then I'm into my SPI flash. 7 gets me into just a GPIO. 8 is a GPIO. So here's my 7, 8 right now. I think these are used, there's some configuration on initialization. I'd have to go back and look up the details on that again, but those are just plain old IO the way I've got them set up. A couple of Ethernet, and then there's an Ethernet interrupt, and I'll have to figure that out later. I think that's what that 9 and 10. So right now this is 9 is my reset, and then this 10 I would have to figure out later where that interrupt comes into play. I've not done anything with that. But that, I believe, goes back to the Digilent example. They're using this pin 10 for that signal, which then connects up over here, I believe. And I think there is an interrupt right there. So that's where that signal's coming over to, is this RTL 8211. Okay, so I think I'm fine there. If I keep on going through this, then after that, I had my UART. So that'd be my 14 and 15. Then I'm into a bunch of signals for the Ethernet. That takes me all the way out here. 28 then is USB all the way out to 39. Then my SD, and then my see my resets. So let's see, pin 46 is my reset. That would have been marked down here. And then I've got GPO 48, 49, 50, 51, 52, and 53. And so when I get down to those, I have those 4, and then I have these 2, Ethernet MDC and MDIO. And I believe those are connected up over here, but I don't know what those are used for yet. So that's something I'll have to learn, but that I believe is matching one of the reference designs that I had seen for that. So then with that, it seems like the other thing I should probably look at is voltages. And there's a line right here that's saying, okay, 0 through 15 are one bank, and then this other bank starts at 16 on up, and you choose the voltages. And when I was doing the schematic, I noted that I put this line across, just saying everything below that is one bank, this other stuff is another bank. And this is where I would choose which voltage levels. So 3.3 and 1.8 is what I need to configure for this. Now, if I do this wrong, I believe I will get an error. So if I say OK, it does tell me that the Ethernet doesn't work with 3.3. I should be using 1.8 or 2.5. So if I go back into that, and that's good because that matches what I'd expect to see based on my schematic documentation. I'm saying I want 3.3 and then 1.8, so this should be 1.8. And then I'll say OK, and I don't get that error. So I think that's looking okay. So peripheral I/O pins. What I really want to make sure is that I didn't run into two major devices that for some reason were overlapping, trying to use the same pins, and that my schematic, the best I can tell, this configuration is lining up with what I see in here. And I can tell where I have some, just general I/O pins that maybe I'll be doing something with later. I remember on my design, I do have some just general I/O pins, any of these that just say PS_MIO. There were, what do we have? 4 of them here. 1, 2, 3, 4, and 3 up here. So those were 7 pins that aren't being used. And those will just go out to this little header right here. And so if I ever want to do something with those pins, there's a ground in those 7 signals in this little header if I want to try to do something with those. Okay, so then I say okay to that. And I did see there was an interrupts. I've not done anything with that before. Interrupts. And no, that's not what I'm looking for the Ethernet side. Okay, so then I think that's it. I think that hopefully looks like I was able to configure it in a way that's consistent with the schematic that I have so far. So I'm going to kind of mark that as a check. I didn't find any major mistakes going through that, but I'll do some more looking at that as I get time here. Maybe the next thing then is I might want to just see if I was to order this up, what's it going to cost? And I'm going to real quick just do a check DRC. And these are just messages I can ignore. I'm going to go over to my PCB and also do a DRC here real quick. And just make sure I didn't have anything messed up from the last time I touched this. Okay, so there are no errors there. And I can now go in and choose to order this up. And so I'm going to do this order PCB. I don't need to check DRC because I just did that. And it pops up on my other screen, but let me slide that across here. And I'll just run through and see if I can configure this up. And so while it's processing the files I uploaded, when it gets done processing that, it should show that it's an 8-layer board, and it's going to be one of these high precision 8-layer boards. And it should automatically figure out the dimensions. I'll order up 5 of these PCBs. And then I'm going to come down here. I can choose things like colors, and it's going to automatically select this ENIG based on it being an 8-layer high precision board. And if I keep going down through this, okay, that finished, I guess. Let me back up. Okay, so it picked 8. It picked my dimensions. And let's see, I'm not going to pick a different color because they charge for that. It picked ENIG. Impedance control, yes. and then I can choose which one. This is the one that I believe I'm going to use. And some of these others, it just tells me that they're not economical. So there's really only one that is they're economical. So that's what I'm going with. And that does match what I've chosen in my stack up over in Easy EDA Pro. For the via covering, I'm going to go epoxy filled and capped. I had to choose my minimum, what's the smallest size I did for vias, and the smallest I went was a 0.3 inner with a 0.4 outer, so I can stick with this option here. If I had to come up to one of these smaller ones, it would take my price up quite a bit. The rest of this I think is good. So let me scan through this one more time and see if I'm missing anything. So it's FR4, 8 layer, ENIG. The material type is this FR4 TG155. It is impedance controlled with this profile or layer stack up. Epoxy filled and capped for the via covering. I've specified my minimum via sizes. It's going to automatically do this flying probe test. So I think I'm okay with that. So if I look at the pricing at the moment, then I can see that, okay, they're going to charge me a $94 engineering fee. And the board is only, for 5 of them, is only $13.70. So the boards themselves really don't cost much. It's just this engineering fee that costs quite a bit. And so then that gets me down to this $107 for 5 of these boards. Now, if I want to do the assembly, and I'm not going to take the time to go through all the detailed bill of materials, but I think it does a decent job of trying to do some of that for me. So let's see, we're going to do standard, both sides, and quantity, it says from 2 to 5. I only want 2. I don't want to produce 5 of these boards. And then I'm going to confirm that. I'm going to go ahead and say next. I want 2 of these, and then I can change or correct that as I go through this. But it says, okay, there's a total of 97 parts. And like somewhere in here would be my actual, let's go find, looking for quantity 2. Okay, here's the actual Zynq itself. So 2 of those is $40. So it's only $20 per Zynq-7000 for that. So I think that's great. But then I can look through this and see what are all the parts, and it seems like it's doing a pretty good job. And I probably need to come in on some of these capacitors and maybe change things around, but I'm going to just run with this for now. It's good enough to give me an idea of what cost it's going to be. And then there's some stuff that they couldn't find parts, and I would have to go through this and see, well, what are they missing? Like these plugs, I wouldn't want them to populate anyways. I have these. It looks like some standoffs. Yeah, I'm not actually going to put standoffs on here. Does look like I have some, well, it's more standoffs. It looks like these would be inductors, so I'll have a little bit of cleanup to do and just make sure I can get all this bill of materials set correctly. But I'm going to just say this is good enough for now. Let's just see where we're at. It says some parts are unselected. I didn't want to do that. I'm going to hit next and just simply say skip those for now. So I'm missing a handful of components as I take a look at this, but let's just see where it comes up with this. So it is doing component placement, and then I'm seeing something that looks like this. And to kind of see what that is all looking like. And that's the top. Here's the bottom. And I can see there's some stuff missing. So there's some capacitors and maybe the flash, and that might maybe be because they don't have a 3D model of it, whatever it might be. But let me just keep going here and see. Okay. And so then it looks like my total now I'm getting up to about $400 US. So $110 for the 5 PCBs, add another just shy of $300. to do all of the assembly, and including really most of the parts I already had that were included there. So I can see a breakdown. There's a setup fee. There's $100 in parts per board. It looks like there's some other fees for loading and assembly, and here's my x-ray fee, etc. So if I want to order 5 PCBs, of which 2 of them will be assembled, I'm in this approximate ballpark of $400 plus maybe $20 in shipping. And so I'll have to choose, do I want to just spend $100 and then go get the parts for $100 and do a board and see if I can get it done myself, or just simply pay the $400, have it assembled for me. And I would still be getting 3 blank boards, so that if I wanted to, for example, just play around with the power rails or other things, I have those boards to experiment with. But I think this is probably what I would do. I think I could get comfortable spending $400. So it looks like I'll be spending $400 at some point here, get a couple of these and see if I can make them work. And, it should again look like something close to this when I get it all said and done. And in my case, I guess it would be green, and I would have a silver. So this is probably closer to what my board might look like when it's done. I don't know, for those of you that do a lot of this, especially the assembly by JLC, PCB, anything here you're seeing that you'd recommend I rethink or change, or just looking for general feedback, anything that you'd catch in this video that I really need to go back and double check. So I think that's where I'm going to stop. I'm going to continue for the next week or two, just reading, checking my schematic, doing some little fine tweaks. But then I think I'm going to get this ordered up and see how that goes.